All right, these are the 7.2 notes for trig. You're going to need your unit circle for this. So if you don't have one at home, I'll make sure you get one. At least I'll put one in the It's Learning so you can look at it. All right, so we're going to be doing trigonometric identities today, and we're just going to be simplifying these. So simplify to a single trig function with no denominator. So for example number 1, I have sine of theta times cosecant of theta. And on your unit circle, you've got these identities down here at the bottom. We don't want to change anything to sine as y or cosine as x. We want to use sine. We want to use cosine, tangent. But for cosecant in them, this is what we're going to focus our attention on here, changing these over to 1 over sine, 1 over cosine, and cosine over sine. And we can even change tangent into sine over cosine. We're not going to change these into x's and y's, though. All right, so when we look at sine, I'm just going to leave it as sine over 1. No need to write anything else or change it to a, we definitely don't want to change it to the letter y. So just sine over 1. You can put the theta there if you want. So let's write a little note. Don't use x or y. All right, now for cosecant. You can see at the bottom of your unit circle, it says that cosecant is equal to 1 over sine. That's what we're going to write for cosecant, 1 over sine. Then because I'm multiplying, I can actually cancel. Sines cancel, one on top of the other. And 1 divided by 1 gets me a final answer of 1. So that's what we mean by simplify to a single trig function with no denominator. All right, for the next one, secant. It says that secant here is equal to 1 over cosine. I'm looking right there. So I'm going to write secant as 1 over cosine. And if you're feeling lazy, you can leave off the theta. The theta is kind of just like an x. So a lot of times I'll leave it off until the end. All right, cotangent, notice right there, is going to be cosine over sine. Not using the x's and the y's, but using the cosines and the sines. All right, now notice what happens. Your cosines cancel, which gives me 1 over sine. That's a pretty good answer, except they want no denominator. So I look back to my unit circle, and 1 over sine right here, 1 over sine is cosecant. So I'll write my final answer as cosecant, and then I'll put that theta back on that I've been too lazy to write every other time. Example 3. Cosecant is going to be 1 over sine. Tangent, sine over cosine. Cotangent, cosine over sine. And cosine is just going to be cosine over 1. So if you even want to add that to your unit circle and just say this is going to be sine over 1 and cosine is going to be cosine over 1, you could do that. All right. And now because everything is being multiplied, you can cancel any sign at the top with any sign at the bottom. So I'm going to cancel that one with that one. Any cosine at the top with any cosine at the bottom. And any number 1 at the top with any number 1 at the bottom. That's going to leave us just this cosine over, at the bottom, sine. But remember, we don't want any denominators. So let's look to our unit circle and see if cosine over sine is something. Let me erase some of this stuff here so we can look at cosine over sine. Here it is down at the bottom. Cosine over sine, right, would be cotangent. So my final answer will be cotangent. And I'll put that theta back on that I left off the whole time. Now for example number 4, sine over cosine. This one doesn't even require any work. Look at your unit circle, sine over cosine right here. Your answer is tangent. So some of the problems are a little bit longer. Other ones are pretty short. For example 5 and 6, for just example number 5, you can see you're dividing. And because cotangent and cosecant are both going to be fractions themselves, we're going to write this as cotangent divided by cosecant. So we're going to write them next to each other instead of one on top of the other. All right, I'll turn those into fractions now. Cotangent, cosine over sine. Cosecant, 1 over sine. And then when we divide, remember you flip the second fraction and multiply. Flip that around. Sine over 1. And you can see that your signs are going to cancel out, leaving you cosine over 1. The 1 underneath doesn't mean anything. Something divided by 1 is still that thing. So we would just have our answer as cosine of theta. When you square things, you could do it the exact same way. So cosine squared, I'm probably just going to write that as cosine squared over 1. You could also separate that out and make it cosine times cosine. Tangent squared. So tangent squared is going to be just the same thing as tangent would be, except for tangent squared would be sine squared, cosine squared. So both of all those things would be squared. Sine squared, cosine squared. And cosine squared cancels with cosine squared, leaving me an answer of sine squared over 1, which I don't need the over 1. And there's my simplified answer. All right, the next part, these are different identities. This is going to be on the back side of your unit circle. And this just has to do with negative angles, meaning going the opposite direction around the unit circle, and what that's going to do to your answer. So if you look at your unit circle, on the back side, you got up in here in the corner these even odd identities right here. And all these things are telling you is whether the answer is going to be a negative if you go the opposite direction or whether it's going to be a positive. So the negative theta inside here, remember, just means rotate around the circle the opposite way. And if I do that for sine, I'm going to get a negative answer. But if I do it for cosine, I'm still going to get a positive answer. If I do it for tangent, I'll get a negative answer. So literally all you're doing is looking at the back of the circle. And if you see this, you write down that. If you see this, you write down that. So they're going to give you one side of the equal sign, you're going to write down the other. All right, so sine of negative theta, as I look at the back of my unit circle, I see that it says negative sine of theta. That's all we need to do. Secant of negative theta, if I look on the back, it says secant of negative theta is regular secant theta. There's no negative. So I'm going to write my answer just like I see it after the equal sign, no negative. And then cotangent of negative theta. Here's my cotangent of negative theta. Notice this one has a negative as your answer, so I write negative cotangent of theta. Those are pretty simple. You're just looking at the unit circle. The next set is pretty easy as well, the Pythagorean identities. This is on the next section down in your notes. Right here, Pythagorean identities. And there's 9 of them. You can see that the first 3 going down are kind of the same thing, but the numbers are just rearranged. Right? Sine squared plus cosine squared equals 1. That's the same if you have 1 minus sine squared equals cosine squared, right? Just the sine is on the other side. And same thing with the last one. Now the cosine's on the other side with the 1. So just different forms of the same equation. So all we're going to do is we're going to look and see what we have and see if it's one of our identities. So the first one is 1 plus cotangent squared. So I'm going to scan all of the options, and I'm looking for 1 plus cotangent squared. Here it is, 1 plus cotangent squared. So my answer is whatever's after the equal sign cosecant squared theta. All right, example 11. I'm looking for sine squared plus cosine squared. Sine squared plus cosine squared. Here it is, the very first one. Sine squared plus cosine squared equals 1. So my answer is just 1. These aren't very helpful on their own, but they play part of a bigger picture later. So we're just going to learn it the most easy way, and then we can add on to it later. Secant squared minus 1. Secant squared minus 1 right there, which will give us an answer of tangent squared. All right, now this last one is a little bit interesting. 1 plus sine we don't have, 1 minus sine we don't have, because these are all squares, right? Pythagorean identity comes from the Pythagorean theorem, a squared plus b squared equals c squared. So you can see that each of these has some squares in it. The only things that aren't squared is the 1, because 1 squared is still 1. So no need to put the square on the 1. So for this part, what I'm going to need to do first, I'm going to need to do some just regular math. Let's FOIL. 1 times 1 is 1. 1 times negative sine is negative sine. Sine times 1 is sine. And sine times negative sine is negative sine squared. Now, just like numbers, signs work the same way. So if I have a negative and a positive sign, those cancel each other out, just like a negative 5 and a positive 5 would cancel each other out. So I'm left with this 1 in front and minus sine squared theta. Now that I'm back into squares, I can look at my Pythagorean identities. 1 minus sine squared. 1 minus sine squared. Here it is right here. 1 minus sine squared is going to be cosine squared. Cosine squared. And there's my final answer.